So today our learning intention is to learn about the sound intensity level, and and how the sound and human perception of the loudness of the sound. So what is intensity? First of all, let's recall what is power in general. What is power? Definition of the power. Energy used per second.
Yeah.
So power is how much energy used per second. A unit of the power is 1 watt, is when 1 joule of energy used in 1 second. Let's consider source of sound, point source of sound, which emits sound evenly in all directions. Emits sound evenly in all directions. And it has power P. Obviously, when it will be spreading out, it will be redistributed over the bigger area. And sound intensity, in letter I, equal power divided by area over which sound is distributed. So unit for intensity, unit of the measurement for intensity will be 1 watt per 1 meter squared. There's no special name, just 1 watt per meter squared. Now, when it's evenly distributing in all directions, it creates a sphere. What the formula for area of a sphere? Who remember?
Is that 4 and 3 pi r cubed?
That's
1 and
volume.
3.
4 pi r squared, yes. So as area of a sphere equal 4 pi r squared, so you have formula for intensity is power of the sound source divided by 4 pi r squared, where r will be distance from the source of the sound to the point where we observing sound. And what's important, as you can see, called one of the inverse squared laws. So intensity decreasing proportionally to r squared. When as bigger r, the smaller intensity. And let's say at the distance of 10 meters from the power source, from the sound source, the intensity is, let's say, 0.5 watts per meter squared. What will be intensity of the same sound at the distance 20 meters? How we will find that? What will be the easiest way to find the intensity of the same sound at 20 meters, at the distance 20 meters of the source?
10 squared on 20 squared equals I squared on 0.5. No, not
So
squared.
how many times distance increased?
To 20. Oh, 10.
How many, not
Oh,
by
two,
how many times? 2 times.
Yeah.
As these are increased 2 times, how many times intensity will decrease?
4.
4 times. So we can just get I2 equals 0.5 divided by 4 equals 0.125 watts per meter square feet. If we have that now distance will be 100 meters. How many times 100 meters greater than 10 meters?
10 times.
10 times. So how many times intensity will decrease?
0.0, it'll be 0.
No, what is how many times it will decrease? 100 times, 10 squared. It will decrease 10 squared times, so 100 times, so it will be equal 0.005 watts per meter squared. Now, but human ear can respond to very, very large range of the sounds. Very big range of sounds. And so there was necessary to introduce, when we're dealing with some quantity that has huge range, hundreds of thousands times smaller value, less than the bigger value. Because the threshold of hearing, have you heard what threshold? Do you understand what does it mean, threshold?
The most you can hear without it hurting.
No,
No,
threshold of hearing.
It's like until you can barely hear it.
It will be the sound that you can hear, the smallest value. And threshold of hearing for human ear is 10 negative 12 watt per meter squared. That is the softest sound that human ear can respond. Later on we will see that it's not the same for different frequencies. That is not the same for different frequencies. This is for frequency of the sound at 1 kilohertz, 1000 hertz.
Will there be like a question on the test being like, can this sound be heard? Will there be a question on the test and it'll be like, can this sound be heard?
No.
Okay.
No. But calculating the intensity and sound intensities will be. Now, and human can be the sound with the intensity of 1 watt per meter squared will be painful. But you see how hugely different it is. 10 in the power of 12. 1 and 12 0. That's so huge range. When we're dealing with some quantity that has so huge range, what type of scale is used? People who would at mathematics should be able to answer this question.
Logarithmic.
Logarithmic scale, yes. Logarithmic scale. So, usually when we're talking about sound loudness, we're not using sound intensity, we're using sound intensity level. Sound intensity level. Yeah. And the definition of the sound that we use for sound intensity level equal 10 times log with the base 10 of sound intensity divided by threshold of hearing. That is a definition of the sound intensity level. And unit is, you probably all heard about such unit, decibel. Yes, decibel. That how decibels are calculated as a sound intensity level. So what will be, now some students in your class learn about logarithms. Pretty much learn everything about the logs. Some have not learned logarithm maybe at all.
Have you done logs?
Yes.
So, main thing what you need to be able, using scientific, get your calculators out please. And on the calculator there is a button that says just log.
It's always base 10.
If it's log base 10. There is another one
Oh, well.
with the ln. It means log, logarithm with the base e. We don't need this. Just on your calculator, there is button with the log. So let's calculate sound intensity level for sound equal with the sound intensity 10 in the negative 11 watts per meter squared. So let's substitute it in this formula. We have L equal 10 log 10, 10 in negative 11 divided by 10 in negative 12. Use your calculators.
10. 1.
It's what?
Oh, no, 10. Because it's 10 times 1.
It is log will be equals 1, because log 10 with the base 10 is 1 times 10 is 10. So it will be 10 decibels.
Wait, Mr. V.
Yes.
Is it 10 times log because it's in decibels? If
Yes.
it was in bells, it would be log 10. with no-
Correct. Correct. So it will be 10 decibels. Now let's calculate what will be the sound intensity level if we have intensity equal 10 in the negative 10 watts per meter squared.
I guess 320. Oh wait, other way around.
20.
No, 10 in negative 10 divided by 10 negative 12.
It's
Yeah.
2.
2 log will be 2 times 10 is 20 decibels.
Why don't just do the how often at the end is
So what pattern can you see?
yes, I got 10. You can just move it down.
If intensity increase, let's do one more to make this pattern more clear. Let's increase intensity
For
10
every
times
time-
more.
For every 10.
10 in negative 9, yes, you are right. M negative
It'll be
2,
30. 'cause for
the
every
level
time
will
it's
be
multiplied by
30
10, it'll go up by 1.
decibel. So if we have that intensity of the sound increase 10 times, sound intensity level increased by 10 decibel. So if the intensity increase by 10 times, sound intensity plus 10
If you do it the times 10 of it.
decibels. Make sense?
Yeah.
Now, let's do small opposite exercise. If we have that sound intensity level equal 55, let's do 50 first, 50 decibel. How we'll find what will be the intensity level. So we substitute into the formula. 50 equals 10 log with the base 10. We have I, unknown intensity level, divided by 10 negative 12.
10 negatives.
So we will have log with the base 10 of I over 10 negative 12 equals 5. When we know log with the base 10 equals 5, what does it mean?
10 to the
I
5.
on 10 to the negative 12 equals 10 to
That
the
I intensity over 10 negative 12 will be equal 10 in the power of 5. Next we times both sides by 10 negative 12 and we'll get intensity equal 10 in negative 7 watts per meter squared. Make sense?
Yeah.
One more example.
Do you have to
No, you can do it. You can, but that's like no one tells us to do it. It's not wrong. Like in math, they only do it that way. Just-
One more example. If you have
It's the same thing as instead of
sound intensity level
to the negative
equal
1 over 10 to the 12.
65 decibel. what will be the intensity of the sound? 65 equals 10 log 10 I over 10 negative 12. Rearranging this form, so we get that log with the base 10, intensity divided by 10 negative 12 equals 6.5. That means I over 10 negative 12 equals what? 10 in the power of 6.5. And so intensity equal 10 in the power 6.5 times 10 negative 12 will be equal 10. What will be 10 in which power?
Negative 18. It's 3 point.
Minus 12 plus 6.5
Yeah.
will be minus
5.5.
5.5.
I thought you were asking for the answer.
And then you put into the calculator and you will get
3.16 times 10 to the negative 18.
10 in power negative 5.5.
Apparently.
No, it cannot be. How 10 negative 5.5?
Mike has it, Mike has it.
0.00003162. A bunch of.
Oh, 10 negative 6, sorry.
3.16
Times 10 to the negative 6.
times 10 negative 6 watts per meter squared. Makes sense how find sound intensity if you know sound intensity level. Make sense? Now, one more example. One more example. If we have if sound intensity doubled, so we have intensity 2 equal 2I1. How much the sound intensity level will change? So we need to find, not level, sound level, we need to find what will be our L2 minus L1.
Oh,
Let's do it.
19.
Will be 10. So we have I1 equal 10 log 10 I1.
So you read L equals.
Sorry, we have L1. L1 equal 10 log 10 I1 on 10 negative 12. L2 equal 10 log 10 I2 over 10 negative 12. Let's subtract them. L2 minus L1. L2 minus L1 equal 10 we can take as a common factor. We have log 10 I2 over 10 negative 12 minus log 10 I1 over 10 negative 12. So for people who have learned logs, when we have a difference of the logs, we divide what is inside the log, and so that will be equal 10 log 10 of I2 divided by I1, which will be equal, because I2 equal 2I1, 10 log 10 2. Okay, use your calculators please. Calculate this value, 10 times log 2 with the base 10.
It's 3.01.
Yes, 3.01.
Oh, logs are no methods exam.
Logs shouldn't be, because it's a semester exam only for semester 2.
Oh, did we do logs last semester?
Really? Thought we did look.
I thought it was like start of this one.
I think it was the very start of the semester.
I don't know.
Yeah, we had a test.
Because we did
after
polynomials, remember?
We learned it last time, but I think we did the test.
Oh, I think we did the test.
No,
after
I
the
don't. I
exam.
don't think that the logs will be on this semester
Okay,
exam.
hopefully not.
I don't think.
Remember how we had.
Okay.
Now, circular functions definitely will be.
Yeah, circular functions.
What?
is fine.
When did we do
We just did
Sine-
Circular functions where
Yeah.
The sine graph, the tan graph.
Okay, now
I hate
So-
graphs still.
for people who don't know log rules, you can use in your calculation the fact that when sound intensity multiplied by 2, sound intensity plus 3 decibel. So when sound intensity doubles to intensity level, you add 3 decibel. Make a note. Make a note. So if you know logs, it's better to go this way. If you do, but this is absolutely will be fine on the test, on exam, if you just use this fact that when sound intensity doubles,
Does a wait when it halves does a -3?
if it halves, minus 3, yes. So if it doubles, plus 3, halves. If it's increased 10 times, you plus 10 decibel. If it decreased 10 times, you minus 10 decibel.
Can't
Yes.
we just use the formula L2 minus L1 equals 10 log with based on I2 and I1?
That will be, the formula will be L2 minus L1 will be equal 10 log 10 of I2 minus over I1. You can use this formula. This is the difference in the intensity, sound intensity levels. But
Yeah.
as I said you, we don't hear sounds even with different frequencies. Sounds of the same intensity but different frequency, our subjective perception will be different. Let's have a look on the next thing. So, let's have a look on this graph. This represents
Yes.
our hearing over the range of the frequencies. As we have sound intensity level on the vertical scale, and we have frequency on the horizontal scale. So as you can see, we have the dashed line is the threshold of hearing. And sorry, I said you that it's was for 0 decibel for 1 kilohertz, but I was wrong. It is actually initially was when it was first investigated. Now it's correct. That is 0 decibel is about a little bit over 2 kilohertz. But the most, like, our ear responds the most, the best to the, and you see this is logarithmic scale. So we have going 20, 30, 40, 50, 60, 70, 80, 90, 100. Then you're going 200, 500, 1000, 2000. This type of graph called logarithmic scale. And we, at what thousand, if you look, we have the most sensitive hearing.
3.5.
Yeah, between 3 and 4 kilohertz. So our ear, the most sensitive to the sounds, between 3 and 4, around 3.5 kilohertz. But if the same intensity sound will be at 100 hertz, same intensity, we will not hear this sound. This sound has to be at about 25 decibels for us to hear. So we have the best hearing like in the area between approximately 500 hertz to about like 6 kilohertz. Then for low frequencies, we need much more powerful sound to hear it. So same loudness across, because it's same sound intensity level. It's all, let's say here 70 decibel. 70 decibel sound. But at 20 hertz, because human ear can respond to the sounds from 20 hertz to 20 kilohertz. Of course, we're talking about the younger people. As older you become, this movement is going to stop hearing the high frequency sounds with the age. So you can hear a little bit later on, I will play sounds with a different frequency and you'll see who can hear what range of frequencies. And you will hear sound, I will stop here, you still will hear those sounds. So it depends on the age. So enjoy music while you're young. As older you are, the less range of the music you will be hearing. So it's all have same, but 20 hertz we will not hear at all. For like 100 hertz, we let's say for 50 hertz, we will hear it same as we hear sound of 40 decibels. So you see how much softer sound at higher frequency. So question is, let's say sound is, you hear sound and those lines are lines of the equal loudness. So along this curve, each of the curves, we hear sound the same loudness. Our subjective perception of the loudness will be the same. If question is, what should be the sound intensity level at 50 hertz to hear it the same as you hear 40 decibel sound at 1 kilohertz. So 40 decibel at 1 kilohertz is here. Then we're moving along this line until we get to 50 hertz.
And past it.
50 hertz. So it has to be 65 decibel to hear it with the same loudness. Make sense?
Yeah.
Okay, that's all of the theory today.